Hi, I'm Dana Edge. I want to talk about midpoint formula, distance formula, and formulas for circles. Let's get a whiteboard. When you look at a point in two-dimensional space, well, let's look at 2 points. Here's a point over here. Here's a point over here. I'm going to call this point 1, 3. 1, 2, 3. And I'm going to call this -3, -1. If we want to look at the midpoint between these, your midpoint is a point, first of all, of course. Halfway between 2 points. And one of the interesting things is that you can determine the x value completely separately from determining the y value. The x value for this point is exactly halfway between the x values for these points. To get a number that is halfway between 2 different numbers, the x for the midpoint here, to get a number that's halfway between 2 numbers, you want to average the x values of the endpoints. And of course, to average 2 numbers, you add them together. So I'm going to add -3 and +1 and divide by 2 because there's 2 numbers. This is -2/2, which is -1. Excuse me. So it looks like the x value for this point is at -1. To get the y for the midpoint, you get the average of the y values at the endpoints. So if we look at the y values, -1 and 3, you notice that this x is lined up here, or this y value rather is lined up here. This one is lined up here. This one is halfway between. So if I take the 2 y values, -1 and 3, and add them together and divide by 2, I'm going to get 2/2, which is 1. So the midpoint is at -1, 1. Your formula to get a midpoint between 2 endpoints is always to take the 2 x values, add them together and divide by 2 to get the x value, and take the y values, add them together, divide by 2 to get the y value. So this is how you get a midpoint between 2 points. The distance formula is a lot more complicated. For the distance formula, we make use of the Pythagorean theorem. You know, on the Pythagorean theorem, if you have a right triangle, a triangle with a right angle, and you label the 2 shorter sides A and B, and then the longer one we call the hypotenuse, label that C, that the squares of the lengths of the legs add up to the square of the third side, the hypotenuse. Well, when we're looking in space like this, we can always draw a right triangle between 2 points. This is making the assumption they're not already lined up horizontally or vertically. So if this is the point x1, y1, and this is the point x sub 2, y sub 2, then the distance from here to here is going to be this distance squared plus this distance squared will give you this distance squared. So here's our A, here's our B, here's our C. This is the point x sub 1, y sub 1. So it might be the point 1, 2, or whatever. It could be negatives, it could be irrational numbers, anything. This is x2, so this is x2. Notice that this is also x sub 2. This is y sub 2. The distance from here to here, let's say this was 1 and this was 7. What's the distance between them? Well, 7 minus 1 is 6, of course. So the distance here is going to be the difference of the two x values. The length of this side is going to be the distance between these two y values. So you just subtract them. So in place of a squared plus b squared equals c squared, we know that a is going to be x2 minus x1, so we're going to square that. B, this distance, is going to be y2 minus y1 squared. You don't have to worry about the order here because you're going to square it, so it's going to come out positive regardless. And instead of C, I'm going to call this D for distance. So this would be D squared. To solve this for D, I just take the square root of both sides. So for instance, if I was asked to find the distance between 3, negative 4 and 2, 6, the distance is the same either direction. So I can call this one x1 and y1, and x2 and y2. And I would say the distance is going to be the great big humongous square root of, subtract the x values. So 2 minus 3, and square that, plus 6 minus negative 4, and square that. So this is going to be negative 1 squared plus 6 minus negative 4 is 6 plus 4. So this is going to be 1 squared is 1, negative 1 squared is 1, plus 10 squared is 100. So the distance is the square root of 100. Now this is your exact distance. If you want the approximate, use a calculator. It's whatever the calculator is going to give you. Now for a circle, the mathematical definition of a circle is that it is the set of all the points a specific distance from a specific point. Imagine you've got some point and you want every single point that is exactly, say, 3 units from here. So let's say this distance is 3. So it'd be that one, and that one, and that one, and that one, and that one. And you get the idea when you start getting every single point that's 3 units from this. It's like if you had a string 3 units long and you anchored it at this point and you attached a pencil to it and you drew it all the way around. Now this point we call the center, duh, and we usually label it HK. We don't use an X and a Y to identify it because it's not actually a point on the circle, although we can't possibly determine where the circle is without knowing it. And the distance we call the radius. As in any circle, the radius is the distance from the center to the outside of the circle. And we logically use an R to represent that. So if we call these points that are on the circle XY, so this is an XY, and this is another XY, and this is another XY, then our distance formula, since it's a certain distance, would give us that the square root of the distance from X to H would be X minus H, and then we square it. And then the distance from Y to K, here's HK here. So the distance here would be Y minus K. Distance formula says square it, that's equal to the distance, which is R. Now with a circle, we typically don't bother writing this big square root the whole time. So we just go ahead and square both sides back again so that we've got it in the form X minus H squared plus, whoops, plus Y minus K squared equals R squared. So if we wanted to write the equation of a circle with the center at 0, 0 and radius 3, that would become X minus 0 squared plus Y minus 0 squared, because this is H and K, equals 3 squared. So we get X squared plus Y squared equals 9. On the other hand, if we wanted to find the center and radius of the circle whose equation is x minus 3 squared plus y plus 6 squared equals, say, I don't know, 50. The center, because the equation for the circle has minus h and minus k in it, where the center is positive h and positive k, this simply means that the signs are going to be different from what you see as the center point compared to what you see in the equation. The center here is going to be at positive 3, negative 6. The radius, r, is going to equal, because this is r squared, it would equal the square root of 50. Now, as a quick review, when we simplify a radical, we want to rewrite the radicand, whatever's inside the radical. We want to factor it into a perfect square, if it's possible to do so, times whatever. And then we simplify it by taking the square root of the one that was a perfect square. So this would become 5 on the square root of 2, would be your exact value. So one more problem with a circle. Suppose it says write the equation of a circle let's say which contains endpoints of a diameter at -2, 5, and let's say 4, 8. Okay, now we're in a mess, because in order to write the equation of the circle, which is going to be in the form x minus h squared plus y minus k squared equals r squared, we've got to have the center, h and k, and we've got to have the radius, r. So let's take a look here. -2, 5. Sorry about that. We've got -2, 5, and then 4, 1, 2, 3, 4, 8, 5, 6, 7, 8 would be about here. And the circle, these are endpoints of a diameter, which means that the circle goes like this. A diameter goes straight through the middle of the circle. Oh, so our center point is going to be the midpoint, right? So first of all, let's get the midpoint. Our midpoint formula is average the x's and average the y's. So we've got 4 plus a negative 2 is the same thing as 4 minus 2 over 2. 8 to 5 is going to be 8 plus 5 squared. So 4 plus negative 2 divided by 2. 8 plus 5 squared divided by 2. So we've got 2 over 2 is 1. And here we've got 13 halves. Life doesn't always come in whole numbers. The radius is going to be the distance from here to here squared, but because the circle formula is essentially the distance formula, we can go ahead and pick one of these. Let's say we pick this one to be x and y. And this is of course HK. So we can plug x and y and h and k into this side and just solve for r squared. So we're going to have 4 minus 1 squared plus 8 minus 13 halves squared equals r squared. This is 3 squared is 9. Plus, let's see, 8 over 1. 8 over 1 minus 13 over 2 would be 16 over 2 minus 13 over 2, which is 3 over 2. And 3 over 2 squared is 9/4. And then again, I still have to get a common denominator again. So 4 over 4. So I've got 36/4 plus 9/4 would equal 45/4. That's a 5 equals r squared. I don't have to worry about the radius because it didn't actually ask for the radius. It asked for the equation of the circle. Make sure you understand what you're looking for, and if you have to go back and check while you're at it, fine. So the equation of the circle is going to be x minus h was 1 squared plus y minus k was 13 halves squared equals 45 over 4. And that's about as hard a problem as you're going to get on these, typically. All right, so sorry about the interruptions. Happens sometimes. This covers midpoint, distance, and the formula for a circle. So I'll see you again next time. Take care. Bye.